First thing, section 8.1. First thing we did in section 8.1. And there's not a whole lot to write down, but I would highly suggest, and a lot of college professors will do stuff like this to you next year, if you're going off to college. They give you the notes, and then Johnny sits there and thinks, well, I don't have to listen. He gave me all the notes. And yeah, that really works real well. I would jot things down to help me out. All right? So even if Ebersole gives you the notes, maybe write some stuff down on each slide or each part, saying, hey, make sure to do this, whatever helps you. And I'm sort of lying to you because most college professors will not do this for you probably. They just expect you to write it all down yourself, and if you don't write it, oh well, that's your own problem.
Mine's not working. It's Ebersole music's not working on the package.
On this, independent and dependent samples. We're going to take a vote here in a minute. Those of you who want to try to do well on this test are going to vote yes that we set some of these people out in the hallway during this time.
Yeah, guys.
Independent, dependent samples. Independent. Remember, with independent, the two samples really don't have anything to do with each other. They're not matched up. Dependent would be something like, if I take your heart rate now, and then I take your heart rate at the start of the test. All right? They match up because I'm comparing you to you. Over here, we're comparing maybe like a Goodyear tire to a Michelin tire. Okay? They don't match up. Does that make sense? So independent, dependent samples. Wasn't anything real hard about that. We used it throughout the chapter. For section 8.1, you're doing a z-test for large samples, for large independent samples, I should say. So remember, n's got to be greater than or equal to 30. This is what your null and alternative hypothesis is going to have to look like on those. And again, on the test, I did separate it 8.1, 8.2, 8.3, 8.4 to try to make it a little easier. But that's what your null and alternative hypothesis should look like for section 8.1. Remember, with this, regardless of which hypothesis we're using, either the first one, second one, or third one, we're always assuming that the two means are equal to each other. So for most of all this chapter, we were assuming that the means were equal, or the proportions were equal, or whatever it is that we were dealing with. Now, when I say that, that doesn't have anything to do with the claim, all right? So the claim is one thing, but when we start the problem, before we ever even know what the claim is, we're saying, hey, we think this mean and this mean should be equal. We think the mean for female IQ should be equal to the mean for male IQ. I put the steps on here for you. I'm not going to go through all these. Just on this one, on this one, that's the Z chart. And you're probably going to, instead of using table 4, you're probably going to use the little chart. Everything on the test is either 1%, 5%, or 10%. So that little chart that's on the front of your packet, use it. And this is the one where 4, 5, and 6, or whatever the numbers are, we're drawing it, deciding if we're left-tailed, right-tailed, or two-tailed, and then finding our critical value and sticking it on there. Shouldn't be anything real new. We did all this last test was sort of the same thing, right? Just different formulas and stuff. For number 6, that's the formula. This is the part that's on the bottom. I didn't write it in there. I put it on there separately. But that's the part, that's your standard deviation. For the interpret, do we want to write A, B, and C for one of them?
No.
Yeah.
First part is your what? Level of significance. That's your alpha. Significance. Can't spell. And remember, that's the alpha. Part 2 comes from where?
Chart.
That comes from the chart, good. That comes from the chart, and the chart, that chart's the one that looks like this. It's a chart and it's got the boxes and that stuff in it. And then the third part does what? Tie to the problem. That, the interpret's the same for all of these, so we'll write it down for that first one. Then we won't write it down for the rest of them. Now, I apologize, because I should have looked at my page, because I just looked at Daniel's up here and he wrote it right in that space. And that space actually says what on it? Calculator, because I don't have this. So calculator, where it says calculator at the bottom of that page, somebody help me out and let's put the steps for using the calculator for this. And remember, if you're using the calculator for this, is it doing the whole problem for you? All it's doing is finding Z. It's finding that test statistic. Finding what you're seeing, if it falls in the rejection region or not the rejection region. So I didn't have this on the notes, but you guys figured it out as we were doing it, and a lot of you decided to do it that way, and that's fine. What's the first thing? What do we hit on our calculators? Stat. Everybody agree with that? You might want to write this down on there. That's why I left that space. Then what? Test. Then what? Two sample z-test. Once you hit the two sample z-test, what are the things that it wants for you to put in there? Let's see if there's one on my desk. X bar.
X bar 1, X bar 2.
So X bar 1, X bar 2, N1, N2, then what? Sigma?
Yeah.
Sigma 1, Sigma 2? Yes, no, maybe?
Yes.
Anything else? Or is that all 6 of them that they want?
It's right tail, deep tail, left tail.
Okay, then it asks you, so once you have all that in, then it's asking you which tail. Not sure what order does it go in, does it, mine's probably gonna be backwards and that's probably gonna confuse somebody, isn't it? But it's gonna ask you which tail. You gotta tell that, how you gonna know which tail? Look at your HA. Your alternative hypothesis. Does that ask you for anything else?
Nope.
Then it just says calculate, right? Is that correct? And then, again, all we're gonna find from this is what? Z. Just look at Z. That's gonna stop you from having to use that big formula right up above there. Alright? Doesn't help you with anything else, doesn't help you tell which one's or or what the null hypothesis, what the alternative is, doesn't help you draw the little graph, doesn't help you decide whether to reject or fail to reject, but it gives you Z so you don't have to do that big long formula.
So we go on.
Yeah.
So like X bar is in the table, because like N is the number of attempts.
Right. So X bar is that's the mean of the first sample and mean of the second sample.
Yeah.
N is the number in the first sample. N1 is, and then N2 is number in the second sample. This is the standard deviation of the first sample, standard deviation of the second sample. All right?
I wanted to make sure.
Yep. Is everybody all right with that? Next one, 8-2. Again, this time, this is what your things are going to look like. Does that look familiar? Yeah, it's exact same as the first one, right? The only difference here is instead of dealing with large samples, now we're dealing with small samples, so anything less than 30. And if we have anything less than 30, what's that tell you got to use? T chart instead of the Z chart. So if it's less than 30, you got to use the T chart. Change that on your paper. Not my day, Sean. I've screwed up like 3 times already, haven't I? That's like a whole decade for me. 3 mess ups. See, now, look. See, you do stuff like that, and then I I don't care if he meant it or not. It made me feel good. That's all I care about. Again, we're assuming that the 2 means of the 2 samples are the same every single time. You really don't care about that. The only reason that you care about that, and I forgot to say it on the first one, was when you get to the formula. When you get to the formula, the top part of the formula is
0.
that second part of it is 0. On this, the thing you got to remember on this one, number 3 right here, you might want to circle that, star it, something. These are the ones where we had to decide whether the variances were equal or not equal. If they're equal, you do one thing. If they're not equal, you do something different. Sorry, on this, write this in. That's part of my thing got erased out here. If they're equal, then that means it's pooled. If the variances are equal, then it's pooled, and we do this. I'm going to put if equal. Is that all right? Can everybody understand that? If equal, we find the degrees of freedom that way. You add the 2 ends and subtract 2, and that gives your degrees of freedom.
That's good.
No, it was a terrible toss because I was trying to hit you in the head.
I know, that's a big target you missed. Reading the BCS ranking in 2007. USF was number 2.
Do I care?
University Center. Really, just some wild facts.
If the variances are not equal, then it's not pooled. I'm saying pooled, not pooled, because on your calculator, it asks you that question. If they're not equal, then what you do is you take the smaller n, whichever one's the smaller one, and to find your degrees of freedom, it's just n minus 1. Whichever one's the smaller. So if your 2 n's are 8 and 18, you take the 8, and you do 8 minus 1 and get 7 for your degrees of freedom. Number 5, again, that's just drawing the little picture, figuring out. And this time, instead of using the front page, we're using the T chart. This is the formula. Again, I'll say it this time. We always know that that second part right there is always what? 0. And that's for the whole chapter. The bottom part down here, notice it says over here on the side, the bottoms are different, and that's on the next couple of slides. The top stays the same, it's just x bar 1 minus x bar 2, and on bottom it's 2 different things. And again, if you use your calculator, you really don't have to worry about that. But you should know that there is a difference. And the difference is this. If the variances are equal, then this is on the bottom. That's the one that all of you love so much. So if the variances are equal, that's what's on the bottom of that fraction. So it's got x bar 1 minus x bar 2, and this is on the bottom. That's if the variances are equal. If the variances are not equal, and the degrees of freedom I have down there, wrote on the last one. If the variances are not equal, then this is just on the bottom. So it's T equals x bar 1 minus x bar 2 over that whole thing there. The second one, if the variances aren't equal, is quite a bit easier than if the variances are equal. But if you know how to use the calculator, then again, you don't have to do the formulas. I do the formulas out every time. That's just because I enjoy doing the math so much, right? Smaller one, calculator. This is how you do it on the calculator. Again, all this is going to tell you, all you're going to find on there is your T. This is for finding the T value that you're going to check on your little picture. That's all it's for, is finding T. Nothing else on there. If you have a list, remember you're doing data for list, stats, if you're just putting in numbers. I just wrote type in all the numbers here because I was lazy. Anybody want to go to the calculator and see what numbers we have to type in on this one? Is it all the same as the first one? Notice this time we're going to t-test instead of the z-test because we're small samples. Is it the same stuff on this one? Anybody look at it?
A little different.
Is it a little different?
It's got S instead of.
It's got S instead of the, so you're typing in x bar 1, x bar 2, n1, n2, s1, and s2. Is that right? Those 6 things. Tell them which tail it is, and tell them whether it's pooled or not pooled. Remember, if the variances are equal, then yes. If variances are not equal, then no.
What is S?
Standard deviation, same as sigma. It's just since we're doing small samples. Next one, the HO and the HA changed a little bit on this one. We were doing t-tests for the differences between 2 means. So now instead of comparing Goodyear tires to Michelin tires, now we're saying what's the difference between Goodyear tires and Michelin tires. This was a little harder, and guaranteed on the test you're going to have to do some of this out longhand. Even though you can use your calculator for some of it, Some of it you have to do out longhand. I'm going to explain which part here in a minute. Notice on this it says mu, and then it's got the little subscript d. That's the difference. So the difference in the means. Is it less than or equal to 0? Is it greater than 0? I don't know about you guys, but these are the ones that confuse me the most because I got to read the problem about 50 times to decide, okay, which way is that alligator mouth going? Maybe you guys understand it better than me. Reading's not my strong suit, so I have to read very, very carefully and then read again and again and again to make sure. All right, so that's saying that we want this to be less than 0 or this to be greater than 0. And it's sort of backwards on some of them because when you're looking at your numbers, you're going to have your list. Let's say this is first number in the first list is 50. The first number in the second list is 40. So when we're subtracting these, 50 minus 40, what do we get? 10. All right? And you got to know, is that what we want? Decide whether you want a positive number, a negative number according to the claim or whatever it is, and that's where this comes in. So are we saying, you know, that the difference should be greater than 0? Are we saying that the difference should be less than 0? Are we saying that the difference should be equal to 0? That just the problem sort of makes it a little confusing. I think this is one of them that I said we want to work together probably. On the chart, this is what you're going to have to fill out on the test because I did put a chart on there, so you're going to have to fill out the chart. You won't have to fill out these two. They'll already be filled out for you. The chart on the test, because I can't get it to switch around, the chart on the test actually goes sideways instead of up and down. Don't let that confuse you. Remember, you can put these into your list on your calculator, and it'll do the math for you. I'm going to move this up. You will have to fill out this chart, so if I put in something like, let's do the 50 and the 40 again. 50 here, 40 there. Difference is 10. What's d squared going to be? 100, good. And then, once you get down here to the bottom, what are you going to do with all these? Add them all up, get that sum. What are you going to do with all these? Add them all up and get that sum. You will have to fill in a chart on the test that's these two columns. Now that doesn't mean that you have to do the whole problem out longhand, but I put that on there, and then you can use the calculator to find your test statistic and other stuff, and we'll talk about that here in a second. Again, if they give you this list, type it into the calculator, put it in on your list, list 1, list 2. You could even put this in on your calculator. Remember we said you go to the title on your calculator and you put in L1 minus L2, hit enter, and it'll put it in there for you. And if this is list 1, this is list 2, this is list 3, you type that into the title. You can even do list 4, which we don't really need list 4 on your calculator. But if you do list 4, if this was list 4, you could put in on the title just L3 squared. All right, and it would do that list for you. So if Brian doesn't feel like doing all the subtracting and the squaring each one separately, could he put all these into his calculator, then just copy the other two lists off his calculator? Yeah. All right. Now Michael's looking at me like, well, that would be stupid, Ebersole. It'd be simpler just to probably subtract them and write them down than to let my calculator do it all. That's up to you. But you do need these 3 lists to be able to do the stuff on your calculator. The first 3. The last one you don't really need. So we go through, we do this, same thing, degrees of freedoms, n minus 1. Again, you're using the T-chart. Draw the graph again. This is the formula. To find d bar, You have to know D bar to be able to do the other stuff. So to find D bar, you add up all the differences, that's in that one column, add all them up, divide by how many of them there are. To find the standard deviation of the differences, it's this formula. And again, you probably don't care about that formula. This is the formula to find the T that you're going to test. But if you put it into your calculator, the calculator will do that for you. You don't have to do all that, but you have to be able to type them in to the list. And then make a decision, reject or fail to reject, interpret it, all the same as all the others. That's how you punch it into your calculator. Put each in a list. Make the next list x1 minus x2, which you type into the title, L1 minus L2. I just explained all that, right? Stat test, t-test. Make sure you're going to just t-test. I think, look on the calculators. Is that the second thing? Is that what it is? It's second on test. So we're just going to t-test, not to the two sample t-test or any of that other stuff, just the t-test. When you put it in, you've got to make sure. Mu0 is 0, frequency is 1. And here you're just going to put in like L3 or whichever list the differences is in. Tell your HA, calculate, and it's going to tell you this. First thing it'll tell you, I'm not sure why that should be on this line. I'm not sure why it's on a separate line. It's going to tell you that T, that's what we're looking for. That's what that big long formula would tell you. It's also going to tell you X bar, which is actually the D bar, and it's also going to tell you the standard deviation, SX, which is actually the standard deviation of the sample. And the P here, might put an X through that P because we don't want to deal with it. That's that P value that we started off last chapter at, and I said, let's not do that anymore. Let's just do it all one way. The last thing, proportions. They're going to look like this, so back to sort of what the others look like before that 8-3. HO and HA, main thing to remember again, how do you know HO? HO always has to have what? For all of these. It's got to be the equal to part, right? It's always got to have either equal to or greater than or equal to or less than or equal to. HA just has the not equal to, less than, or greater than. And that's for all of them. This is the formula again. You can use a calculator. This is one. I don't ever use a calculator for this one. This part right here, the second part again is going to be 0 every time. Do P hat 1 minus P hat 2. Oh, let's go back and we'll just write it right here. You might want to write this down somewhere. Remember that P hat equals X over N. So if you don't know what P hat is, you can find it by taking the yeses over the total. And that's for P hat 1 or P hat 2. And then the other thing you can do, if you don't know what X is, because your calculator is going to ask you for X and N, if you don't know what X is, if they didn't tell you the number of yeses, but they told you what P hat was, you take N times P hat, and that's going to tell you what X is. So you might have to do that before you have the information that you can plug into your calculator. So those are two key things here, especially this one right here. Because on your calculator, it's going to ask you for x1, x2, n1, n2. I think that's basically all it asks you for on these, because then it does the proportions itself. Interpret it, same as the others. This is how we do it on the calculator. Why do I keep doing that? I had it all written right here and I just explained it before I get to it. Guess I just don't trust myself. So you gotta find x1, x2 before you do it. You do that by doing this. The calculator's gonna ask you to put in those 4 things. That's going to ask you what the HA is, calculate. Then when it tells you your answer, it's going to tell you all of these things. The Z, that's what we're looking for to test on our little curve. It'll tell you what P hat 1 and P hat 2 is. And it'll also at the bottom tell you what P hat is. Well, P hat is our P bar for these problems. Go ahead and grab a study guide.
Would you like to flag?
Try to find it.
69. 1360.
Gage, you wouldn't have said something.
Here. It said 6,420. And then I said $13.69. That's it. I'm selling my artwork.
You're an adult, Gage.
I walk all the way back to the desk. It's too bad. One of
You're an adult.
in this class.
Those numbers aren't funny.
I know.
Those numbers aren't funny.
You're laughing.
No, wait.
On the review packet, first thing I want to do, look at number 8. Then we can do any others that you want to see worked. Number 8. Number 8 is the one with the chart. Again, on the test, sort of looks like this. Looks exactly like this. I shouldn't say that. The chart looks exactly like this. The numbers are different. All right? So the chart looks this way. First thing I want to do on this, grab your calculators and type in the before in list 1 and the after in list 2. I know, but we got to type these 2 lists into the calculator to be able to do the other stuff. I just want you to make sure that you can understand how to do it when it comes test time. You two.
They won't work.
We getting pretty close? Once you get those two lists typed in, go to list 3 or whichever list is next. All right, I don't know which list you put it in. If you put it in list 1, list 2, then go to list 3 and scroll up till you're on that L3, till that L3 is highlighted. And then type in L1 minus L2. So you have to hit second, then number 1, and then second, number 2. Then that list is going to tell you the differences. Somebody read off your list to me. 9? Negative 9?
10, 2, 3, 4,
That's a 2, all right? Can everybody?
no, not anymore. 3,
3?
4, 7, 14, negative 3, negative 10.
What's
Negative 3.
Negative 3, negative 10? That's 14, right? Now, on the test, you're going to have to fill in this part of the chart also, and this part, these two things. This part is unnecessary. The d squared is unnecessary for the test statistic, all right? Because the calculator will do all that for you when we get to that point. But let's go ahead and fill this in. First, somebody add up all these for us.
31.
Anybody else get 31?
Good job.
Now, if we weren't going to use our calculator to find the z or the t, we'd need to know d bar. And d bar is just that number that you just got, 31, divided by how many of them there are. How many of them were there? 10. And that's just 3.1. So that's d bar if we were going to use the formulas. But if we're not going to use the formulas, then the calculator will tell us that when we plug it in. Anybody do all these yet?
Yeah.
169,
81, 100, 4, 9, 16, 49, 196, 9, and 100.
And somebody add all those up for us.
733. That's what I got. I don't know if that's right.
That's right. That's what I got.
733?
That ain't right?
No, that's what I got the first time. But that's not what I have on my paper now. I don't know, what did I add wrong? I added it up 3 times and 100, 4, 9, 16, 49. Now I see it. I subtracted wrong. I said 116 minus 102 is 4. Huh?
So it is 733.
Yeah. Teach me to do something over again, won't it? I did it the second time, thinking, all right, I want to make sure I did this right. I did it second time, did it wrong, and then I believed that way instead of the other way.
Right, just do it. Let's go for it.
Right, that's what I should have, never ever check anything.
Nope.
Now, next thing, let's go ahead and finish out this problem. Part B. The problem says, a medical researcher wants to test the effects of calcium supplements on men's blood pressure. In part of the study, 10 randomly selected men are given a calcium supplement for 12 weeks. The researcher measures the men's blood pressure in millimeters before and after the 12-week study and records the results shown below. At a 1% level of significance, can the researcher claim that the men's blood pressure decreased or stayed the same? So we've got to write our HO and our HA. What's our HO going to be?
Main difference is less than or equal to 0.
That's our claim, isn't it? That's what they're saying. They're saying, this is the one I said I have trouble with because I got to think, okay, which one do we want? It's less than or equal to 0. So, is that right?
I don't know.
Saying that's why I have trouble with it.
The blood pressure decreased, meaning the
So,
number
the
is
difference-
smaller. So then you subtract a bigger number by a smaller number, it means it be above 0.
So the first one we went, the guy's blood pressure was 112, then his blood pressure was 99. Was that a good thing or a bad thing? That is a good thing for the researcher, right? Because the blood pressure went down. So when we did that subtraction, we got a positive 13.
So that's not good.
So the positive 13 when we did the subtraction, so this should be what? Should be flipped around. The researcher wants the difference between the two to be greater than or equal to 0. So what's that mean our HA is going to be? Just less than 0, right? Letter C. Letter C, we got to draw our little graph. Looking at our HA here. Left-tailed, right-tailed, or two-tailed? Left-tailed. For this one, we got to find, or we need our alpha. What's our alpha?
0.01.
0.01, 1%. And we need our degrees of freedom. How many items did we have? 10 minus 1, which is 9. And then what chart are you going to use? Z or T? T chart. Anytime you're finding the degrees of freedom, you're probably going to use the T chart. So on the T chart, somebody help me out. 9.01 for a left tail. Make sure you got those charts when you come in here Friday. Anybody get a number?
2.821. Negative 2.821.
2.821. So that's our picture. Now to find our T, to find our test statistic that we're going to test over here in this, now you can go back and use your calculator. On your calculator, go to, since you put them in the list, you go to stat, test, and which one is it? It's the
T-test.
just the T-test, right? It's just the T-test. Hit enter. What's it ask you for?
Well, you put the data.
Oh yeah, that's right. So
Ask you for
it says data or stats. This time we want data, right? So highlight the data, and you're going to put in which list? List 3 or whichever list you put the differences in. And what else does it ask you for? Tail. Does it ask you for the tail next? So we're left-tailed, or the alligator mouse pointing towards the left. Then you hit calculate. What's it tell you that your T is? 1.1.
7. If you round.
1.17. Does everybody agree with that?
Top 4%.
So that's what we're going with, 1.17? Then next one, letter E, and I'm not gonna write the last two up here because I'm out of space. So you can write them down on your paper. Decide whether to reject or fail to reject for letter E. Is that 1.17, is it in the rejection region or not in the rejection region? It's not. First of all, it's positive, so it can't be in the negative rejection region, right? So what do we write for letter E? Fail to reject the null. Next one, interpret. First part's going to say with what? 1% level of significance. So that's the first sentence. With the 1% level of significance. You can read it.
It is legible.
If I die tonight, I've done something big in this life. With the 1% level of significance, then we got to go to the chart. Anybody got their chart out?
There is not enough evidence to reject the claim.
There is not enough evidence to reject the claim. Everybody agree with that? Just because it's Gage and he's a genius?
He does have his photo up in
There is not enough evidence to reject the claim. There is not enough evidence to reject the claim.
that blank.
You gonna leave that last part just blank?
To reject.
The claim that the calcium supplements do what?
Decrease or decrease the blood pressure.
Close. Decrease or, you started to say it,
Stay.
or keep the same the blood pressure. And the way I wrote it, the calcium supplements keep the same or reduce the blood pressure of the men. I think it was men, wasn't it? Or am I just being a
It's good.
sexist
Ebersole
pig?
likes to take blood pressure medicine for
No, I lower my blood pressure when I throw markers at you.
You miss.
He's
Throw it back up.
Phoenix,
What?
do you really think I would have missed if I would have wanted this?
Yes.
Oh,
Wait, I wanna see it. I think you should try it.
You're gonna pause real quick.
I guarantee I would hit you right between the four eyes.
I wanna see it.
Or right in the middle of your forehead.
Find out.
No, I'm not gonna throw anything. That'd just get me in trouble.
This is weird. We're learning. We're experimenting.
I gotta make sure I fix that one in.
We're in a meeting, 76 degrees outside.
Other questions that you want to see worked off of this? We got about 20 minutes. I'll do any others if you want to see them. Otherwise, I'm gonna go sit down.
You're good.
Test on Friday.
Put your notes back.
If you want to see them, don't be afraid to ask. You don't need them.
I wrote it down.
How's your spring break, Mr. Ebersole?
Better now, because I'm here watching you do math work, and that makes me feel good.
Does it?
Yes.
I appreciate it. You know, everyone on the baseball team has been being mean to me here recently, except for Sim. I was about to say. I try. They all make fun of me. They do. And they don't even make fun of me because I suck. They just make fun of me for no reason.
How we make fun of you?
Ben was making fun of his run.
They make fun of the
That
way I
was not
run. They
me.
say
That was not me. That was, I think
they
that-
said some
I don't know who that was.
mean things to me.
Nobody's got